It says, in order to complete this activity, some specific vocab must be introduced. All triangles have 3 sides. In right triangles, as we know, the side that's directly across from the 90-degree angle in the drawing here, that would be this side here, AB, is what we call the hypotenuse. If you are asked to find the side opposite of angle A, so here's angle A right here, the side opposite is directly across from this 35-degree angle. I don't know if you can read that says 35, but it is a 35-degree angle there. So the side opposite the 35-degree angle is what you would be looking for if they asked you which side is opposite from angle A. Okay? It says that the side adjacent to angle A is the third side, AC. So your hypotenuse will never be considered the opposite side or the adjacent side. It will always be referred to as the hypotenuse. The adjacent side and the opposite side just depend on what angle it is you're looking at. So if I'm looking at angle A, opposite or directly across from it is BC. Adjacent to it would be this side here, AC. Remember, adjacent means right beside, right? So it has to have a side that includes angle A. All right? Of course, opposite and adjacent are just relative terms, like I was saying. It depends on what angle it is that you're looking at. So in this exact same picture, if you were asked to find the side opposite of angle B, if I'm looking at angle B, now AC is the opposite side, right? And BC is the adjacent side. But your hypotenuse will not change, right? The hypotenuse is always the one directly across from that 90-degree angle. Okay, so opposite is going to be directly across from whatever angle they tell you to look at. Adjacent is the one beside the angle they tell you to look at. And then your hypotenuse stays the same, always directly across from that 90-degree angle. So then it says here, just remember that opposite means directly across from the angle, while adjacent is going to mean the side next to the angle that is not the hypotenuse. Hypotenuse is hypotenuse. Okay, so it says you are going to work with a partner and determine which side or relationship is being asked for. So, for example, on number 1, part A says which side is opposite angle M. Okay, so here is my angle M, right? What side is opposite from angle M? Right. So that's what we're going to put on the line. All right? So I want you and the people sitting in your row to fill in these questions, and then we're going to check our answers together here in just a minute, okay? Give you guys a second to do that. 1. Part B. Which side was the hypotenuse? MN. Very good. And part C, which side was adjacent to angle N? NP. Very good. All right, on number 2, which side was opposite of angle Q? Good. Okay, and which side was adjacent to angle Q? Good. And which side was the hypotenuse? Good. All right, on number 3, it says YZ is blank to angle Z. Is it adjacent or opposite? Adjacent, good. All right, and XY is blank to angle X. Adjacent as well, good. All right, and then on number 4, CB is what to angle A? Opposite, good. And CB is blank to angle B. Nice. Okay, so now that we can identify which sides are the opposite and adjacent sides, as well as the hypotenuse, if you'll flip it over onto the next page, it now says with your partner, you are going to measure each side of these 2 triangles using centimeters. Okay, so Maybe if you're in a group of two, one person measures the side of one triangle and the other person does the other, but you need to find the measurement for each of the three sides for each triangle, and you're going to write those side lengths on these lines here, okay? So we're just trying to get as close as we can. So some of us may be 0.1 of a centimeter different than our neighbor, but as long as we're close, we're okay. And we'll share what we get in just a second. So for PQ, what did we get for PQ? 3? 2.8 would be 2.8, 2.9, maybe 2.7 if you had it scooted a little bit. Okay, what about QR? 1.9, 1.8, somewhere in there. What about PR? Good. What about DE? Good. And EF? Good. And DF? 5. Pretty much right at 5. Maybe 5.1 or 4.9, but all of your guys' measurements should be within 0.1 of these. Okay? All right. So now that we have side lengths for each one of these, it says we are now going to calculate the ratios. So first we're going to start with PQR. So I'm only looking at these three measurements right now. It says first we want the side opposite of the 40-degree angle. So if I look in my picture, which side is opposite the 40-degree angle? QR. And what did we say the measure of QR was? Right. So I would have 1.8. Okay. Then they said they want the hypotenuse. What's the hypotenuse? PQ. And what did we say the length of PQ was? 2.8, huh? Okay. All right, so we have the ratio of 1.8 over 2.8. What is 1.8 divided by 2.8, approximately? It says we're going to go 2 decimal places here. 0.64. Okay. All right, then they say they want the side that is adjacent to the 40-degree angle. What's the adjacent side? PR over the hypotenuse, which you guys already told me was PQ, right? And we said that PR was how long? Good. Over that hypotenuse, which y'all said was 2.8. So what is 2.2 divided by 2.8? Good. All right, and then for the last one, they want opposite over adjacent. So you guys said the opposite was QR, and the adjacent was PR. So we're going to have 1.8 over 2.2. And what does that simplify to? 0.8. Good. All right, so here are the ratios of the sides for triangle PQR. All right, now we're going to do the same thing for the larger triangle DEF. So for triangle DEF, what's the opposite side from the 40-degree angle? Good. And what's the hypotenuse? DE. Good. All right, what did we say the length of EF was? Good. And DE? Nice. And the ratio 4.2 divided by 6.5 is going to give us, good. All right. Okay, what's the adjacent side to the 40-degree angle? Good. Over the hypotenuse, which is still DE. What's the length of DF? Good. Over that same hypotenuse. And 5 divided by 6.5 simplifies to, good. All right, then the last ratio asks for opposite over adjacent. So we said opposite was EF and adjacent was DF. So So those are going to end up being 4.2 over 5. And what's that going to simplify to? Good. All right, so we have our ratios for all of the different side lengths. Okay? If you will flip it over onto the last page, they ask us some questions about what we just found on these two triangles. So, it says, are the ratios from triangle PQR column pretty close to the ratios that you got in the DEF column? What do we think? Yeah, pretty close? Okay. Why do you think that that's the case? They both have a 40-degree angle. Do they have any other angles in common? The 90. Well, if they have two angles in common, what do we know about the third angle? It's also going to have to be congruent, right? So all the angles are congruent. Are they the exact same triangle? Are they the same size? What do we call triangles that have the same degree of angles but are not necessarily the exact same size? Not congruent, but similar, right? So these must be similar triangles because the angles are congruent and the sides seem to be proportional, right? We got those same ratios. Good. Okay, so we can say this is because the triangles are similar. That their ratios are the same. Okay, good. All right, then it says, using your calculator, they want you to determine what the values of sine of 40, cosine of 40, and tangent of 40 are. And to make sure that your calculator is in degree mode. So hold on just a second on this. All right, so to pull that up, you're going to press this button that says mode right beside second. And it's going to bring up this list of different things for you to choose from. It's the third one down. So currently the word radian is highlighted. So you're going to arrow down to that row, arrow over to highlight the word degree, and hit enter so that it'll save it in degree mode. Okay, so everybody got it in degree mode? So just make sure that word is highlighted, press enter to save it. Okay. All right, so then you're going to go back to your home screen, and they want us to determine the values of sine of 40, cosine of 40, and tangent of 40. All right, so there are buttons for each of those right here. So we're going to start with sine. So you'll press the button that says S-I-N right here. And it should open a parenthesis. You're going to put 40 in the parenthesis, close the parenthesis, and hit enter. And it'll give you what sine of 40 approximately is. Just like previously, we're just going to go 2 decimal places. So this would be approximately what? 0.64, very good. Okay, so sine is approximately 0.64. All right, we're going to do the same for cosine. So now I've just pressed that button that says cosine, and I'm going to type in 40 degrees, close parenthesis, and it tells us that sine is approximately what? Good. On this line, we have that cosine of 40 is 0.77. And then lastly, we do the same for tangent. So I press that button that says tangent, put in 40 degrees, and tangent is approximately 0.84. Good. Okay. All right. So then it asks, how do these 3 answers that we just got compare to the answers that we had for our ratios on the 2 triangles? So what do we notice? Anything? They're pretty much exactly the same, right? Or at least extremely close, maybe a decimal or so off, okay? So we notice that the decimals are extremely close. So they go on to explain why that is. It says, it is a mathematical fact that for any right triangle that has an angle of 40 degrees, like the ones we were just looking at, that if you take the measure of the opposite side and divide it by the hypotenuse, you will always get 0.64. If it has a 40-degree angle, it doesn't matter what the side lengths are. When you divide opposite by hypotenuse, you're always going to get approximately 0.64. This is what you call sine of 40 degrees. Also, for any right triangle that has a 40-degree angle, if you take the adjacent side and divide it by the hypotenuse, no matter what the side lengths are, you're always going to get approximately 0.77. This is what cosine of 40 degrees is. And then, similarly, if you have your opposite side divided by your adjacent side in a 40-degree angle, then you will always get approximately 0.84, which is what we call tangent of 40 degrees. Okay, so these little terms right here, sin, cos, and tan, are just abbreviations for the words sine, cosine, and tangent. All right? So, now that we know that that's the case, this is true no matter what the degree of the angle is that you're looking at. Whenever your angle, they're calling it theta here, that's what that symbol is, the Greek symbol for theta, as long as the angle is the same every time, so if you're always looking at a triangle with an angle of 57 degrees, whenever you set up those ratios of opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, no matter what your side lengths are, it's always going to end up simplifying down to the same thing. Okay? So, that being said, our ratios that we will always be setting up to find either the missing angle or a missing side is going to be from sine, cosine, and tangent. So it will always be sine or sine of your angle, we'll just call it theta for now, is always going to be the ratio opposite over hypotenuse. So if this was the angle that I'm looking at, where it says theta, if they ask me to find sine, I'm always going to use opposite over hypotenuse. Now in that exact same triangle, if they tell us to do cosine, or cosine of theta, I'm always going to use adjacent over hypotenuse. Okay? And lastly, if they ask you to find tangent of an angle, or use tangent to find a missing side, then you'll have tangent or tangent of theta is equal to opposite over adjacent. Okay, so these are the three ratios that you'll use depending on what you know and what you're missing, right? Because we only know how to solve for one thing at a time. So maybe they only give you the opposite and adjacent sides and they ask you to find this angle. You could use this ratio because the only thing that would be missing is the angle, right? So it just depends on what you're missing, but you will always use one of these three ratios. Now, how do we remember what the ratios are? So there's a, what do they call them? Where it's like the first letter is like supposed to, is that, I can't think of the word. I'm not an English teacher, so not my thing. Oh, what?
Alliteration?
No, that's when it's like the same word that starts with the same letter, right? Like, yes, an acronym. Yes, thank you. So we have an acronym, and it's a funny word. So at first, it's going to seem like you're not going to remember it, but after a while, everyone will just be yelling it out all the time. Every time I ask for the answer to a question, that's what I'll get for the next few weeks. But the acronym is SOHCAHTOA, okay? So the first part of that is so, and it's S-O-H, okay? The S stands for sine. The O-H is the ratio, opposite over hypotenuse, okay? The next part of the acronym is the CAH, C-A-H, which is cosine is equal to adjacent over hypotenuse. Okay, and then the last part is TOA. T-O-A. This is tangent is equal to opposite over adjacent. Okay. So, like I said, it's a funny word, but after a while it starts to click, and then that's what your answer will be to everything. I think people just start to like to say it after a while. So, this is how you're going to remember what ratios to set up. All right?